Good morning, good afternoon, everybody. Today, we're going to be looking at factoring or finding the greatest common factor. This video is for section 6.1, objective 1.
We will be learning how to factor polynomials. The first step to factoring a polynomial is to factor out a greatest common factor if there is one other than 1 or -1. So to help us do that, we're first going to learn how to recognize the greatest common factor of a list of integers. Let's review some vocabulary words, though, before we do that. We know 2 times 5 is equal to 10. We call 2 a factor. We call 5 a factor. And we call 10 the product. Do you see that we can also say that 2 times 5 is a factored form of 10? Now keep those vocabulary words in mind, and let's now look at the same thing but with polynomials. For example, we know that x plus 4 times x plus 5. I'll let you check me on the multiplication, but that is x squared plus 9x plus 20. So let's use those same vocabulary words. Since this times this is equal to this, we call x plus 4 a factor, x plus 5 a factor, and we call this trinomial a product, so we can say also that this is a factored form of this. All right, so keep those vocabulary words in mind because I will be using them throughout this segment, and let's see how we find the greatest common factor of a list of integers. Finding the greatest common factor of a list of integers, step 1.
Okay, guys, make sure you write these definitions down in this first box that's under objective 1. Number 1 is write each number as a product of the prime numbers. Identify the blank, common. The product of all common prime numbers found in step 2 is...
Write each number as a product of prime numbers. Step 2, identify the common prime factors. And then step 3, the product of all common prime factors found in step 2 is the greatest common factor. If there are no common prime factors, the greatest common factor is 1. So let's find the greatest common factor of 36 and 90. First, we want to find the prime factorization of each number. In other words, write each number as a product of prime numbers. Remember what a prime number is. A prime number is a natural number other than 1 whose only factors are 1 and itself. So, for example, the first prime number or the smallest prime number is 2, then 3. 4 is not a prime number because 4 has factors of not only 1 and itself 4, but also 4 has factors of 2. So let's write 36 as a product of prime numbers. You can use a factor tree if you want. You can think of any two numbers whose product is 36. I know 4 times 9 is 36. 4 is not prime, 9 is not prime, but 4 can be written as 2 times 2, and 2 is a prime number. 9 can be written as 3 times 3. So these are prime numbers, and I've written 36 as a product of prime numbers. What about 90 as a product of prime numbers? I just like to think of two numbers whose product is 90. What about 10 times 9? All right, 10 is 2 times 5, and then 9 is 3 times 3. These are all prime numbers, so I've written 90 as a product of prime numbers. Now remember step 2, we identify common prime factors. Do we have any prime factors in common to these two numbers? Well, I'll go ahead and circle anything in common. There's a common 2. There's a common 3, and another common 3, and that's it. That's all of our common prime factors. So the greatest common factor is the product of the common prime factors. Don't list each one of these that I've circled. List each circled number or pair of numbers once. So I had a common factor of 2. I'll write down 2 one time. Common factor of 3. I'll write down 3 one time. Common factor of 3. I'll write that down one time. That product is 2 times 3 is 6. 6 times 3 is 18. 18 is the greatest common factor. Think of what that means. 18 is the largest number that is a factor of 36 and also a factor of 90. So make sure you can find the greatest common factor of a list of integers.
Okay, guys, that's it for the objective 1. The next slide will be for objective 2.